Okay, so we're gonna continue here, and I just want to kind of review. What do the numbers mean, and what do we figure out? Well, we're trying to make the robot move based on an encoder count, based on a sensor, not based on battery power. So we had to employ a sensor that's on the robot. In this case, the left encoder, and we set up what's called a condition. It says that if this encoder is less than a certain number, do something. And this is going to remain true until it reaches 1800, then it's going to jump out and do something else. But what do we figure out? Well, we know that one rotation with the encoder is 360, and that's a good number. We also figured out that in the first leg, we wanted to go 1.8 meters. Okay? So we set our condition originally to say, while the sensor value left encoder is less than 360, because we know that 360 is one sensor rotation. So we wanted to figure out how far the robot went in one rotation. So what do we get? Well, we had 0.28, and that's how we're going to figure out how we're going to move our robot here. And we're going to do some math. So if I said 1.8 meters divided by one rotation, which is 0.28 meters, that equals roughly 6.4285, so whatever. Okay, 6.42. Now, what do I want to do with that? That's telling me that the encoder needs to rotate 6.42 times to get 1.8 meters. So, well, how many encoder ticks is that going to be? It's going to be a whole lot more than 360. So I'm going to take 6.42 times 360, and that's going to give me roughly 2,311. Now, again, do not use point, okay, because the program won't understand that. That's called a floating integer. We don't want that. So 2,311 is the magic number. And that's what I put in here, 2,311. So one of the important things that I did in my left and right point turns, after I told them to go a certain distance as far as turning, I shut them off. I turn off the motors completely. If you don't do this, the next thing that happens is going to interfere with your next move. So I've reached my first leg. I've initiated my left point turn. So let me download this and make sure it works so you can see it. Now, if you drag this slider bar, actually let me minimize this for just a second. Many of you have this slider bar that's all the way down, but if you bring it up, and what you can do when you bring this slider bar up, you can actually see the left and right encoders. Right now they're set to 0. So if I bring up my virtual world, I'm going to watch this for a minute. Go to camera 2 here. And you can see how the encoder itself starts to move. And once I get to my left turn, it will stop. Okay. Now right now the encoder, because the robot took a turn, the left motors had to move backwards. You can see how they reversed a little bit, and it's showing. Alright, so what I'm going to do is I'm going to clear this out, and I'm going to figure out how far I want to go for my next move, my second leg. So I want to figure out my target distance. I'm going to click show, I'm going to click add, and I'm going to click a point of where I want to go. So it's telling me I want to go to 1.55 meters to get to here, and then I will initiate my right point turn. So my second target is 1.55 meters. Alright, so I'll go back to the dock here. I'm going to plug that in. 1.55 meters. And I'm going to do the same math I did before. 1.55 divided by 0.28. That equals 5.535. Alright, so I'm going to estimate that to be 5.4. Sorry, 5.54. And how many rotations on the encoder is that going to be? Well, I'm going to figure that out by saying 5.54 times 360. That's going to equal 1994.4. Again, we're not using the period. And just so you know, 1994 was a great year. That's the year I graduated. Love that number, 1994. Yeah, that long ago. Yeah, I'm old. Okay, so what I'm going to do here is I'm going to copy this while statement, and I'm going to bring it down here to my second turn, my second leg. Now here's what you're going to have to do. One, you're going to have to change the condition to be a different number, our second leg, 1.55 meters. And two, you're going to have to clear the encoders. And that's one of the things I put in the document for you. This is kind of a major thing. You can definitely do a weight and definitely clear your encoder. I'm not using the right encoder, so the left encoder will be just fine. So I'm going to do a weight. And always good to delay a robot because of gravity and inertia and all that good stuff. And then I'm going to say capital S, sensor, capital V. Okay, I want to spell that right, capital V. Oh, struggling today. And it should autofill. And I want to tell it that I want to use the left encoder, and that should pop up for you. Good. And all I'm going to say is equals 0 followed by that. Okay, so that gives you a little wait time after your turn, lets the robot chill for a second. So I'm going to download this and make sure this works. And again, I probably should have adjusted my turn to be a little bit better. So I'm going to just do a refresh here. Camera 2. I'm going to turn this off so I don't see that anymore, and I'm going to press play and see what happens. So obviously it's going to go leg 1, no problem. Does my left turn, it pauses for a minute, and here we go. And that will track, and again I'm looking at my sensors here, to the rotation. So now I want to initiate my right point turn, calculate my next leg, right point turn, calculate the final leg, and checkpoint is finished. Okay, so yes, this is going to be a big program once you kind of go through, but again, you're copying and pasting, and some of you are going to figure out how to make this a void statement and employ variables so you can change it each time. Now that's going to be a video for later on this week. We're going to revise this a little bit. Anyway, miss you guys a lot. Hopefully you can go through these videos and figure this out. Please collaborate with each other, even though you have to distance, but help each other out so we're all on the same page when we move on. Have a good day.